Welcome to In 5 Minutes. In this video, we are going to study interrupt-driven I/O access method. In the last video, we saw how program I/O device access method works. The drawback of the programmed I/O is that every time processor needs to wait and repeatedly check the status of I/O device till it's completed operation. So basically, the cycles of the processors are wasted till the I/O device completes its operation. The solution to this problem is that the processor can issue an IO command to a device and can continue executing other instructions, and there should be some signal from the device such that it can notify the processor when it has completed its operation. And after that, the data will be exchanged between IO device and the processor. So this is the basic principle of operation for the interrupt driven IO access method. In this case, the data transfer is initiated by the device and through the interrupt signal. Now we will see this access method from the point of view of device as well as processor. So from the perspective of IO module first is going to receive the input output command from the processor. Then it proceeds to read data from the address peripheral. It's doing is function assigned to it. Then once data is fetched in the buffer, or if it is write operation, then the data buffer is completely transferred to the output device. It issues the interrupt to processor and waits. So it notifies the processor that the operation is complete. When processor is going to request that particular data, the data is transferred to the processor. So this is the way in which the IO module responds to the read operation in interrupt driven IO. Now, from the viewpoint of processor, first it is going to issue the IO command to the input module, and it is going to continue to other instruction. So once the command is issued, it can execute the next instruction in the sequence. At the end of each next instruction, it is going to check for the interrupt, whether the interrupt from the IO module is arrived or not. When the interrupt actually occurs, then first it is going to save the current program information, and then after that it is going to process the interrupt. During the processing of interrupt, the data exchange between input output device, the CPU and memory is operated. In this way, we have seen the both ways of interrupt driven IO access methods from the IO module perspective and processor perspective. Now we are going to see the entire flowchart of the interrupt driven IO. The first step in the flowchart is issue the read command to the IO device. Then processor continues to execute the next instruction in the sequence. So there is no dependency involved in this step. At the second step, whenever the interrupt from the IO device occurs, that is during this period, the IO device has completed its operation and ready to transfer the data. So after interrupt occurs, the processor is going to read the status from the IO module, then check the status for errors. If there are errors, then go for error condition processing. If it is ready, then we are going to read the word from the IO module. So basically the data transfer between IO and CPU occurs in this step. Finally, writing the word into memory. So the CPU to memory data transfer. So here you can see how CPU acts as an intermediate between input output device and the memory for the data transfer. And finally, we are going to check whether the operation is completed or we need to read more words. So if no, then again we have to issue the read command, then follow the same cycle. Otherwise, we can go to the next IO instruction in the sequence. So in this way, the interrupt driven IO is functioning. Therefore, the main advantage, as you can see here, that there is no dependency or waiting of the processor while the IO module completes instruction. The two important concepts in the interrupt driven IO are how the processor actually processes the interrupt when it occurs, and the second thing that we want to see is if there are multiple IO devices present and then they are going to generate multiple interrupts, then how processor is going to handle multiple interrupts with multiple devices. So in the next video, we are going to focus on these two concepts. So please stay tuned for more. Thank you.